Hi everyone. I think before I go to the talk, I just wondering because it's different for every XCon. How many of you are developers and still writing code in day to day? Can you raise your hand? Oh, nice, a lot. I'm not sure if people who not raise a hand, maybe some of you is still too, but anyway. So yeah, last year I heard a lot about AI being a software development and it was amazing. So I made an attempt to it. Let's try and build real software using AI. What is the real software? I'm thinking about e-commerce because e-commerce is quite a big thing. Then I opened the Cloud Code. Let's see how it goes. Please build me e-commerce website. Use some framework that I know. And then I got this e-com store. It's a text, but this is not exactly what I'm looking for. But I'm not going here to talk now about AI because I think more interesting question is, that is the starting point. Where do I go from here if I'm gonna use AI for my software development? And by exploring that, I think we're gonna see what is the fundamental similarities between building software using AI and using handcraft code. And yeah, that is my talk today. Okay, so where do we go from here? So I think the first common things to do is to complain. This is not e-commerce website. It doesn't have even product list. It doesn't have product details. And so I prompt the AI, here is what product detail page and the home page should look like. Okay, this is not that text. Okay, not that text. And I got this one after that, which is, getting closer and getting better. But I think sometimes we're going through this cycle without actually reflect on what's actually happening. So have you ever thought about what we are really doing here? What we are doing over there by complaining is actually we are breaking the problem down into smaller and solvable steps. Okay? And you can see even before the AI world, when you have big requests like your client come in and I want new e-commerce website, I want new engineering platform, anything. What you need to do first? You need to break it down, right? Okay, what is entail in e-commerce website? It has to have a home page, a detail page. And when you come up with this, then you need to break down even more. Oh, home page needs API and front end. And in the API level, you have certain architectures. Maybe you use MVC, so you need controller. Or maybe you have clear architecture, so you need to break down into repository levels. And that hasn't changed when you handcraft code and when you use AI to do the code. Still, there's two fundamental steps for non-trivial software engineering, which is turn the big problem into trivially solvable steps. And once you got small enough problem that you can solve, then you start to solve all these small problems, right? And this thing you can do it by handcraft the code, or you can do it using AI. But still, the structure is the same. So let's talk a little bit about nature of when you coding via LLM. And if we look at when I try the e-commerce, right, it seems like AI is very good at that what things, solve small problems. But when very third break, we have a very big problem, it's doing such a good job. That is because there is one fundamental thing in the LLM architecture, fundamental problem. Not really a problem, just limitation, but when LLM context get overloaded, there is an attention mechanism where it needs to pay attention to all the context, right? And even though you have such a large, big context, but when you give AI too much context, then the performance starts to drop. And you can see this is a experiment for research from that. And see, when you start to give more context, then at this point it's drop dramatically. Drop. It happened to Claude, every model. So the takeaway here is that you cannot build real software by just giving AI 300 pages of specs and it will not happen because of this context rot. I don't think this limitation gonna be solved as long as LLM architecture still like this. Maybe we need new architecture, but maybe they can solve it. I don't know. I just make my own prediction anyway. So if we talk about now, then we had talked about LLM is better at coding, but that means that it's becoming better and better at solving small but difficult problems. And if you look at all the AI benchmarkings that all the provider has been using when they say that it's getting better at coding, if you really look at what kind of test that they do, it's actually testing around I would say hard lead code problems where it's very difficult, but the scope is really clear. You have input, you expect that output, things like that, within the performance characteristic or so on. But when we have maybe simpler but large problems, then it doesn't really work well. If you look at e-commerce, it doesn't really need that the first search, binary tree, or advanced algorithm, right? It's just big, but not really have difficult problem. For large problems, at least for now, that require a lot of context. LLM doesn't able to solve it well. And that is also, if you look at how coding tools and works, it actually doing this breakdown. So I'm gonna talk it a little bit more later on. Or even context engineering that become big buzzword today. Do you know prompt engineering? Anyone know prompt engineering? Raise your hand. Anyone heard about context engineering? So I want to clarify this a little bit. One thing that I think is happening before when AI came up, prompt engineering was a big thing. And prompt engineering always talk about you should give AI more context. It's talk about you should have one-shot example, you should have the role, and you should have more and more context. Around last year, we just start to discover that actually if we give it too many context, it doesn't really work. And now that's why many people came up with new terms, context engineering, and it talks about how you should give the right amount of context. And it become principle when you design agentic systems. So people who design the system already embed these principles. But as an AI user, if we understand that there is a point where too many contexts make things worse, then we start to be able to utilize AI much more effectively. Now, big shot prompt doesn't work well. You want to build a e-commerce website? Doesn't work. But when you start to break down, and it can break down in different ways. I can break down in product list page, product detail page, or I can break it down in a way that can you build the database first, can you build the API first, and so on. And different type of breakdown lead to different type of system as well. I will go back into the coding tool. If you take a look at many techniques that AI coding tool use, it's really about breaking problem into smaller context-free problems. Cloud Code have this plan mode, and when they recommend that if you build something big, you should use plan mode first. And the plan mode is actually just asking AI to break down into to-do list first and do execute to do one by one. So you see it's still around the principle of reducing the amount of work and amount of context any given time. Spec-driven development, a lot of spec-driven development is a overloaded term where it can point to different workflows because spec kit have one workflow, Kiro have another workflow. But all the common things of any spec-driven development kit is build the spec first, then plan, then execute. And you see it's still about breaking down. Or even the team of agent, the way that it works is actually breaking down the problems to context independent so an agent can work itself. And so segue a little bit. People talking about you can have agentic team, you can have agent of software architecture, back-end engineer, QA, and working in tandem, and it can build large stuff for you. I want to say that this also riding on the principle of managing context as well, because if you don't use agentic, right, what happens if you start to say that you are senior architect, design this software, and it's print out architecture design, and after that you say to the AI that now you are software engineer, you implement this, it gets confused by the two contexts. And what the reason that agentic workflow works better than doing this, because you just cut it here. Now it gets less context and it can work more effectively, get less and more focused context. So the breaking down matter, because if you have QA agent, but the QA testing require you to know all about how software engineer implement the feature. Now you need to fetch all the context about how it's implementing, and this agentic workflow gonna not perform well because now you bombard the context. And I think the industry is, I don't know, maybe not the industry, but I think many times we focus on the wrong thing. This effectiveness is not come from we have multiple roles, but it's about managing the context. But people talk about this so effective because you have multiple roles, kind of, but it's not really the point. The point is to manage the context. So the first fundamental skill that doesn't change at all is breaking the big problems to smaller and context-free solvable problems. So what do you mean by that? What do I mean by that? Then let's say that you want to fix, the system offer expensive promotion to the client, not the optimal one. If you give them the AI that context that we are building e-commerce, template of specs, user certify, they click this, please stop me. It's not going to work well. It's too many contexts, irrelevant context, right? You give it everything just to solve one small thing. It's too many irrelevant data and it starts to drop. But if you say that, hey, can you write the function that find minimum given array and proportion and provide that to the user, it becomes more focused and it gonna work much better. And the left one is what I mean by context heavy, because you need a lot of context to just do things. And this is more context free and lighter. And this scenario, LLM is naturally more performant. Now, then the next question that you might ask is that, well, then can we ask LLM to break things down for us? The answer is technically yes, but there's two problems. So the first problem is that there is a probabilistic accumulation. If you have too big of the problem and you break it down to like 100 steps, right? Then each of the problem, because LLM is still non-deterministic, so there's a chance that it do things wrong. But if you accumulate this enough, then the probability of success is gonna be reduced, like 99% for each. Now it's become 36% overall. And this is the reason why we still need some checkpoints, human checkpoints as well, right? To not accumulate too many non-deterministic steps. I think it's very important for us is internal structure matters. I don't think that software is not something that you just solve the problem according to specification, because you still need to progress. And it's not just a build once artifact, right? It's not throw away. Software is not really throw away. So how you devise system really matters. So when I did the e-commerce, this thing, what it gave me the product table. And you can see that the price and stock is embedded into the product. That does mean that this e-commerce won't, at least at this stage, won't support multi-price, won't support promotion, because product gonna have one price. And even like a stock variant where you might have iPhone black and white and so on, it will not support because it's just one it's in the same. You can, But if you look at the current state, it actually works. When you have one problem, one specification, there is many ways to build software and make it works, okay? But different way of structuring the software inside will lead to different trade-offs. Should I try to AI to design it as scalable as possible immediately? Maybe, maybe not. What I gain might be scalability, but then if I start to separate out pricing module from the products, decouple it, I start to decouple the stock system, amount of code increase, the response time gonna be a little bit slower because it's not in the same table anymore. Resource efficiency gonna decrease a little bit. But if we look at current requirement, both structures still work and still fulfill the requirement. But there's an internal trade-off. And what are you looking for? That's a very big question. And even if we still ditch the idea of handcrafting code, right? When we break down the structure, also it affects how we prompt as well. So I can say that create product module, product should have price, and it prompt the AI to have price in the product. But if I say that we can use create pricing module separately, or I say that making sure it support multiple price upfront, it will output the different structure. So that means that second fundamental skill is because one requirement can be solved in many different ways. So understand trade-offs between each type of breakdown is the second fundamental skills that still remain even if you don't do coding by hand at all. So manual or AI-assisted code, 3 steps still remain essential. Define the problem clearly. I did not talk about that for this talk, but that's the first step. Breaking it down and choose. Breaking it down in multiple ways so you have multiple solutions and you choose the right trade-off. These are still fundamentals to software engineering. Okay, but wait. If I look into one book, which is Fundamental of Software Architecture, and it says that the first law of software architecture is about trade-off, right? It's trade-off. So when I talk about this, am I trick or encourage you to learn more about software architecture? The answer is a little bit complicated. It's yes and no, because software architect is a little bit of overloaded term as well. So some people say that it's all about architecture, but some people say it needs to be big impact enough to call software architecture, and small impact one is called software design. But anyway, that aside, one thing I know for sure is that your ability to come up with multiple solutions and choose the appropriate one, that will be matters regardless of the tool change. Even if you don't hold the software architect role and you might working a little bit in the that's possible for a little bit smaller scale, there are still a lot of things that you can choose. Like if you work in small scale, you can choose things like, should we use array hash map? Should we run cohesive functions or T-separate functions? Is it method should be in existing class or new class, right? Even the small problems, there's a lot of choice that we can actually make. Medium scale, like SQL or ORM. Do we do REST API, resource-based or task-based? Or do you have acceptance criteria in integration test or unit test? Things like this. And in large scale where like people with titles of architect might take a focus on is things like microservice or monolith, sync or async, containerization or serverless. But you can see that it's still like multiple ways to solve one problem with different trade-offs. And I work in like all scale through my career, and even when I work as software architect, if you ask me, can I build e-commerce with any of these buzzwords, I would say, yes, of course. I can build it using microservice or monolith. I can build it using containerized app or in on-premise with a bare metal. And I can build it using cloud native or not. Like everything works. I can build e-commerce with literally any this buzzword, it works. But my skill is be able to look at the organization, look at the business context, and choose the right buzzword for those organizations. If I choose monolith, then we get simple infrastructure, more stable connection between subsystems because it's not network call, right? Just function call. That's much more stable. But what I lose is I cannot do intermittent release, and it's become problem in large teams. I lose autonomy within team because people need to coordinate release or making sure that they're not stepping in each other's tools. And if I use event instead of request, event-driven architecture instead of request response, then I get decoupling language. They get multiple subscriber, but at the same time I lose, there's not guaranteed response anymore because things is asynchronously. There's a complexity that comes with tracing. If I choose request response, then opposite side. If you just give me the spec of e-commerce, I can build using any of this. But if you give me more context of organization and business, I can choose the right one. In other words, I would encourage you to be skillful as software architecture, and this is not about finding particular solution, one solution, but it's more about choosing the appropriate solution. So, after all this talk, what now for everyone? So, what have we learned? First, due to context degradation, we now established that AI can solve problem to certain size, but once it gets bigger than that, we need to break it down. And we learned that each method of breaking down provides different trade-offs. And ability for software engineer or for us, ability to break down one single problem into multiple solutions and choose the appropriate one, that still remains value for us. Okay. If I want to build e-commerce site, I can use any of this, right? I already talked about that. But so for you, especially maybe younger generation, I would encourage that if you want to still work in industry, because now single solution come easier, we encourage you to practice this. So first, when you have the problem, try come up with multiple ways to solve the same problems, different type of breakdowns. Take a look at those solutions and see if it's solved. If both can solve, then what is the trade-off here? And once you start to learn about that, then you can start choosing, look at the bigger context and choosing the right solution for those contexts. In the world where LLM can provide initial solution really quick and become easy, then ability to choose solution matters a lot. I think this chip is start from the beginning because it start earlier than AI era. If you look at around 1990, then at that time, software architecture is more about just finding anything that it works. It's really hard to come up with working solution. Just one, that is hard. But as 2000, 2010, more and more, it's become easier. Like today, if you ask me about what kind of language I can use to build a big e-commerce with 100 million users, I say any language. I have seen Ruby on Rails, which is not really performant, still works. So now, it's not about finding one solution anymore. It's more about you understand, you can break it down to multiple solutions, understand the trade-offs, and choose the right one. And yeah, I choose this talk because I think there are a lot of anxiety between what is the value of us as a software engineer and how can we still contribute to the industry. And for me, right, when clients come to me, then they know that I can give them the appropriate solution. And that's why personally, I don't think I am afraid much about losing the job because of AI. But then, yeah, I want to share that if you can go to this stage, I think you're going to be pretty in the secure spot too. But that starts from my younger days where I look into one problems and I think about hey, what if I break into, like when I was junior software engineer, I was thinking about, if I break into 2 classes, what's the difference? If I make 3 classes, what is different? And so on. And I accumulate those kind of thinking into these days. And here's where I am. And I want you to share that. That can be something that you can try to, if you still want to stay in this industry, regardless of AI or handcraft code, this is still relevant. Thank you.